Hello everyone, this is KP the Math G, awakening to a nice beautiful day. Hopefully you're ready to study some calculus with me this morning. What we're going to do this morning is we're going to revolve a solid about a line. And this is exactly the same problem as yesterday's video, but there is one exception. We're going to revolve this area bounded by x equals 2 and y equals 1, and of course the line itself, okay, about the x-axis. So we're going to revolve it about this axis here. Alright, right here. In yesterday's video we revolved it about the line y equals 1. But if you notice about that one, you got a disk from that one. It's a solid of revolution. This one is going to be the washer method. You're going to be left with a hole, okay? You're going to have a solid part right here, and your hole is going to be here when you revolve this. Alright, can you picture it being down here? I'm just kind of giving you an idea of what it might do. Alright, it's going to taper off like that and go straight down like this, and it's going to see, this is your hole right here. Alright, this is your hole part right here, right in here, okay? And then from here on, the rest of it is solid, okay? But this is a space. Anytime you have a space, you're going to have a hole, okay? Alright, so let me just kind of also, let me erase this word hole in here and give you another thought, okay? And you've probably seen this in textbooks, probably so, but I want to show you myself, you know. This is how we measure. Anytime you're dealing with a hole, you have two radiuses, a large radius and a shorter radius. The first radius is the hole plus the solid part. That is the big radius, okay? But you also got to subtract off the hole. So you have to subtract off this part right here, okay? And that is little r right there, okay? So it's going to be this long radius, including the hole, plus, or minus rather, take away this here, okay? Alright, and it's also always in that form pi r squared. Alright, so it's going to be a big radius squared minus a smaller radius squared. I showed that in a previous video, but you know, if you haven't watched my videos, this is a good time to see that, right? Alright, so you're going to go, you'll have pi, and you'll go from A to B, alright, like that. Alright, and then big R squared minus little r squared. And that's always the case, dx, dy, depending on which way you're running your isolated. But that, in this case, we are dealing with delta x because we're running this isolated along that, perpendicular to that rather. Alright, so now let's look at this. Let's erase this down to here, okay? And let's see if we can set up the equation. I like to go ahead and let's just talk about this for a moment. Alright, now there's my offset interval that I'm drawing here. Right there. We know that this is delta x. Right here, that's the thickness. So I know that somewhere down here I've got delta x. I'll put that up there in just a moment. Alright, here's this little lot. Okay, so now, what is this height here? I measured it all the way down to the x-axis, which I should do. Alright. Let me show you something, folks. Here's one, here's two. If x is 2, what do we go up to? Alright, we go up to 1. If x is 2, we go up one space, up. Just like that. That's how high up we go, right? The y value. Alright, so in this case, in that case, that was a number. It's 1. But what is this right here? We still got, this is x, right here. Y is here. Alright. What is this y? How far is it? This is y. This distance right here is y. So if I were to come out right here and come out right here, this distance from here to here is y. Well, what is y? Well, y is 2x plus 1. This height is 2x. Doesn't matter where your interval is, it's still going to be y. Okay? I just kind of choose to put it somewhere close to the middle, but it doesn't matter where I put that. Choose to put that offset interval. It's still going to be y. Now, here's our hole right here. Did you see that? Now this is a radius. It's going to form a diameter, but we have a radius here. We go by the radius. How high up is that radius? Alright. Now, by the way, this is actually big R. This is our big radius. The height here, all the way up. Start from the x-axis and go all the way up. Okay? That is y. Okay? How high is this? Well, we know. From 0 to 1. There it is. This is r, which is 1. Alright, the whole is the radius, which is 1. So little r is equal to 1 unit. And so, according to the pattern then, we're going to take this big R and we're going to square that minus, this is y. Well, we already know what y is, okay? Minus 1 squared and the whole thing. Now, delta x. Alright, dx. Alright. The only thing about it is now is what to do about this. Well, this interval goes from 0 to 2, doesn't it? I can scoot this offset interval all the way over to 0, but no further, and no further than 2. So from 0 to 2. And actually what I did here was, this is y squared minus the little r. Alright? And y happens to be 2x plus 1. Okay? That's this y, the big radius, alright, minus the little radius, the whole. And anytime you have that, you're going to have something squared minus something else squared. Okay? If you have a solid of revolution, if it's solid all the way through and through, it's not going to be a big R minus squared minus a little r squared. Just one thing squared. Okay? And that's the difference. Okay. Now, we have this. Let's square this. This is going to be 4x squared. And I always like the first one is squared. The first term is squared. 2x times 2x. Okay? This one right here, plus sign. 2x times 1 is 2x. But remember, you double that, so times 2, so that's 4x. And then 1 times 1 is 1. The last term is squared. And then now you still got minus 1 squared, but 1 squared is 1, so 1 minus 1. Alright, dx. Well, now we can subtract 1 minus 1, and we're left with I, 0 to 2. Now 4x plus 4x squared, rather, plus 4x, and then this is 0 right here, right? And dx here. Alright, there it is. The idea is just learning how to set this up. Y squared minus 1 squared. Well, we know, again, y squared is 2x. Y is 2x plus 1. So I'm squaring that y. See? I'm going to flip this over. It's 4x squared plus 4x dx. Alright, so let's do that. I've elected to do one problem at a time because I try doing two, and I feel like I do you a disservice when I try to do two problems. Okay, we're going from 0 to 2. I believe it was 4x squared plus 4x dx, right? Yeah. Now, if you wanted to, you could factor out a 4 and put it out here with this pi, but that's not really necessary unless you just really want to. You can take out a 4 and put it out there with that pi, and that would make it a little bit better, but it's okay as it is. Okay, so equal to pi, and now we're integrating. Okay, at this point we're integrating from 0 to 2. Okay. Alright, let's see. 4x squared. I'm going to add 1 and put that down here. Okay, so that's going to be 4x cubed over 3. Alright, plus. Alright, now this one's going to be 4x, and I'm going to square that and divide by 2. But 4 over 2 is 2. Alright, so that's just 2x squared. Alright, 2 goes into 1 time, 2 goes into 4 2 times, so I'm left with 2x squared here. So 2x squared. Alright. Alright. Okay, that's good. Let me erase this right here. Just make sure you integrate properly. I believe I have. You know, you add 1 and then put it down here. You add 1, put it down there. And we simplified that, so there we go there. Okay. Now we can just put in the numbers. So now we have pi. Okay. 4 times 2 cubed over 3 plus 2 times 2 squared. And then if you want, you know it's minus 4 times 0 cubed. I always get, when I know I'm plugging in 0 and I see x's in every term, you know what all of this is going to be, right? That's right, it's going to all be 0. Okay? Because 0 cubed is 0, 0 times 4/3 is 0, 0 squared is 0, 0 times 2 is 0. This is all 0 here. So really all we're looking at is this part right here. If you're in an AP class, you might just want to say this is 0. You may not even have to plug this in, okay? Unless your instructor tells you to do that, okay? But if your instructor does not, at least acknowledge that that is a 0. Maybe that's, I would say you need to do that. All right, let's carry on with the answer now. Pi. Now let's see, 2 cubed is 8. We don't multiply 4 times 2 first, do we? No. Okay, 2 cubed is 8. So 8 times 4, or 4 times 8 is 32. So this is 32 over 3. Alright, plus, okay, 2 squared is 4. 4 times 2 is 8. Alright. And if you remember how I did this on previous videos, is I multiply 3 times 8 and get 24. Okay, I'm getting a common denominator. Alright, so here's pi. Alright, 32 over 3. Alright, 3 times 8 is 24. 24 thirds is the same as 8. Okay, just like that. Okay. And then we're just going to add these two up. So this should be 2 plus 4 is 6. 3 plus 2 is 5. Alright, 56 over 3 pi. Okay. Now, here's the thing that I want to say here. 3 won't go into 56. And the reason I know this is that 5 plus 6 is 11, and 3 won't go into 11. So sometimes we need to might be aware or be reminded of how we know that a number will go into another number. All you have to do is add up the digits. Okay, so 11 won't go, 3 won't go into 11, so 3 will not go into 56. So just leave it like this. Okay. Okay, that's that. And I want to just do one more thing before we end the lesson. Let's say that this has been changed. I'm going to erase this part right here. Alright, let's say this is changed from the x-axis to x equals -1. So now that means that we're going down to this line here. X, not, I mean y. My goodness, y equals -1. All right. I hope the other one didn't say x either. This should be y. Okay. What now? Now we got a different situation. We got to bring our absolute interval all the way down right here. We got to bring our absolute interval here. Now, all the way down. Now, we're not going to solve this one, but let's at least set it up. We know that we're going from 0 to 2, and we know that there's going to be pi here. We know that we got something squared, and we know that we got minus something squared here. Alright? And dx at the end. Okay. Let's fill in these two blanks. Let's fill in these two. Okay. What is this height here? Well, we already know from our last example that from the x-axis up, and that's how you get y, this is y. Okay? This part right here is y. I'm not counting from here up. I'm counting from here up. We know this height is y. And then now, we need an additional part here to get the big R. So I know it's more than just y now. How much more? One more, isn't it? Right? So y, this is y. This height here is 1. So y plus 1. Now y, which is 2x plus 1. Alright, so y plus 1 squared, that's the big Y. How big or how tall is this hole? Well, from the last example, this height is 1, and I know it goes down to -1, but you still count the absolute value of that, y'all. The rest is also 1. This radius here, this little r, is 2. That's it. Now, of course, y is, we don't want to leave it like that. Okay? But that's what we're talking about. So here, pi from 0 to 2, now y is 2x plus 1 plus 1, 2x plus 1 plus 1 squared. Alright, minus 2 squared dx. 1 plus 1 is 2. Alright, so there we go. There it is. And you can keep going down this way. And you might be asking me, well, KP to math G, what would it be like up here? That's another lesson, okay? We'll have to study that. But I just wanted to, as you keep going down further and further, and you're going to notice that these numbers on the end, that's going to subtract off to 0. Okay, so and we're still going to be left with the rest of it to do. But anyway, that's it. I mean, this is what it was. Y plus 1, that would be 2x plus 1 plus 1. Just like that. Okay? Alright. Alright, there it is. Anyway, I love doing this. I appreciate everyone tuning in. I do appreciate the likes. If you would like to comment, well done, keep it up, or whatever. I appreciate that. If you have something that you would say, hey, KP the Math G, I can show you a better way. As I always say, if you're going to show me a better way, be correct. And I'm willing to change. I'm willing to do something that's better to make you better. It makes me better, and it makes you better. If you would like to subscribe, hit that subscribe button. I'm getting more and more subscribers. I appreciate that so much. It is encouraging. And like to make a comment, make a comment. But anyway, at any rate, whether you do or don't, if you learn something from this, that's all that really matters to me. KP the Math G signing off. Have a great day.